yesterday.
So today we're going to be getting into section 3.4 on exponential logarithmic functions. We're just going to cover the very beginnings of this section. It's not going to take us very long. And so today, if you notice what it says, there's a one-to-one property of exponential functions. It says for b is greater than 0, for b being positive and b not equal to 1. B to the x equals b to the y if and only if x equals y. So basically what's going to happen is you're going to want to write equations with the same basis, and then what you'll do is set their exponents equal to each other. So in this case it says if 3 to the x equals 3 to the 5, then x equals 5, because your exponents are equal. Okay, over here it says if log x equals 3, remember that's log base 10, then 10 to the log x is 10 to the 10 cubed. Okay, so basically what they're saying there is this, and we've already done that. And you're going to notice a lot of the stuff we're doing is going to look really familiar to stuff we've done in the past. This whole chapter relates to each other in every section. So we've got about 3 problems we're going to look at. You'll have a few problems that you'll need to start on, and then we'll get through section 4. Probably we'll continue Friday, and if we don't get done Friday, we'll go into Monday. Test, you're looking at about Wednesday or Thursday of next week, probably both days. So, solve each equation. 36 to the x plus 1 equals 6 to the x plus 6. Now, in order to solve this, you have to get the same basis. And so I need to look at the two numbers, 36 and 6, and I need to think to myself, is there a base that's in common, or is there something that I can write both 6 and 36 as a power of?
6 or 3?
And you already know that 36 is 6 squared. So that's what I'm going to write that as, and then I've got to the x plus 1 power, and then on the right side I have 6 to the x plus 6. Now in looking at that, when you have in this case 6 squared to the x plus 1, this is a power to a power. What do you do with the 2 and the x plus 1? You multiply them. So really you get 2x plus 2, and then that equals 6 to the x plus 6. Now that property that we looked at on the very first page stated that if you have the same basis, all you do is set the exponents equal to each other. Well, I have the same basis here, so all I'm going to do is write my equation right there. 2x plus 2 equals x plus 6. And all I need to do now is solve that for x, and that will be my answer. So first thing I can do is subtract x. I can also subtract 2. So you end up getting x to equal 4. And there you go. That's it. So your whole goal, to get the number with the same base, set the exponents equal. And that's pretty much what we're going to be doing today. So let's go ahead and look at another one. Okay, so now I think about 1/2 and 64, and I think, okay, what number can I write both 1/2 and 64 as a power of?
2.
Yeah, 2. Okay, I know that 1/2 is 2 to what power? Negative 1. Excellent. Nice job on that one.
How do you know that?
Because we taught it is.
Because it's a fraction, remember, if I want to move the 2 up, since it's 2 to the first in the denominator, I can move it up and make it 2 to the negative first. 64 is 2 to what power?
4. No.
I think it's bigger.
Yeah, it's
Bigger, bigger, bigger.
6.
2 to the what?
6.
6th. Okay. So now all I need to do is go ahead and apply my properties of exponents. And so on the left side I have 2 to the
Negative 1x.
negative 1x equals, on the right, 2 to the,
6.
Halves.
yep, 6 halves, which is 3. Okay.
Oh, yeah, I got it. Yeah, there we go. That makes sense.
Okay, so basically, if you didn't catch what we did, we took negative 1 times x, got negative 1x. We took 6 times 1/2, which is 3. Now all I have to do is set my exponents equal. So negative 1x equals equals 3.
So the answer's
Divide by negative 1, so x equals negative 3. Pretty straightforward. We've got one more we're going to look at today, and then we'll be done.
Equal 1.2 million
Okay, 2/3 to the x minus 5 equals 9/4 to the 3x over 4. There's actually two ways of doing this problem. What do you know about 2/3 and 9/4 if you compare them?
They both go in the bottom.
What?
The same.
It's 2 and 3. So, well, what about 9 and 4 in relation to 2 and 3? 3 squared over 2 squared, right? So really, when I think about it, I know that 9/4 really equals 3/2 squared, right? Okay, so what I could do over here is I could write this as 3/2 quantity squared, and then all of that is to the 3x over 4 power.
Ooh, that looks just tough though, right there.
So now I need to think, how could I write 2/3 as 3/2?
3 over 2 to
Inverse.
the -1.
It's to the -1, right? And then I know originally it's to the x minus 5. Now don't get confused by the extra sets of parentheses. The reason why we did that is so that you understood that both the 2 and the 3 have to the -1 power. Both the 2 and the 3 are squared. Okay, it's not just the 3. And so now what we're going to do is, notice here I have a power to a power. So really, I end up having 3/2 to what power on the left side? Negative x plus 5. For those of you wondering where that came from, I had to distribute that -1 to both the x and the 5. On the right side, I'm going to take 2 times 3/4. What is 2 times 3/4?
6
X.
plus 8.
6x over 4, which is 3x over
Oh, 2.
2. Thank you. Okay, for those of you wondering how did that happen, it was 6x over 4 actually, and 6x over 4 we know reduces down to 3x over 2. Final step, bases are the same, we now can set things equal, and so I ended up with negative x plus 5 equals 3/2 x, or 3x over 2. We know that 3/2 x is equivalent to 1.5. So I'm going to go ahead and add 1x to both sides. On the left I get 5. On the right I get,
2.5x.
2.5x, which is 5/2. So to solve this, what are you going to do?
It's 2.
Multiply by 2 over 5. In which case you get x to equal 2. Okay, nice job. All right, so now what I need you to do is start a new assignment. Okay, and what you're going to do on that new assignment is you're going to go ahead and start section 4. It's 1 through 8. Tomorrow the plan is that you're going to have a quiz, and we're going through section 3, and probably a worksheet or group work of something. So,